Welcome to this session. So we are going to talk today about the cadence optimization process. We already started this process about a year ago, and we are now in the middle of it. So we felt that it would be good to share where we stand with the community. So I'm presenting this on behalf of the Survey Cadence Optimization Committee, which includes about a dozen people and is empowered to make these final cadence optimization decisions. So I will refer to this committee as SCOC, and I will give you membership list in a few slides. Now, why is this not advancing? Oh, it is. I see. So just to remind you, as a community, we agreed to a set of conduct rules, and not following these rules will not be tolerated by the project and by the community. You know which rules these are now by the third day of the meeting. You know that everything is recorded too. Show your appreciation at the end. So what are we going to talk about today? There are actually 3 sessions about the survey strategy. If you didn't have a chance to go through the agenda in detail, it might be a little bit confusing. So the SCOC organized 2 sessions. So this session, the first one, I will provide a high-level overview of the SCOC process and timeline for making decisions. And then following half an hour later, there will be a session organized by Peter Yorkin and Lynn Jones, the 2 project members who are leading the scheduler development and the production of simulations that you all are using and assessing how good are various survey strategy ideas. And then there is a 3rd session tomorrow organized by Sarah Bonito that was organized by Science Collaborations, and it's centered on their discussion of survey strategy in multiple breakout rooms. I just learned last night that Sarah Bonito is an accomplished musician playing ukulele and playing in a band of astronomers in Palermo. That's impressive. So why do we have this committee? You know that we had baseline for how we would deploy the observatory to obtain data for the legacy survey space and time, well over a decade. And so in the beginning, this baseline cadence that we started with was essentially a proof of concept that we can accomplish all the scientific goals that we advanced when we asked the federal government and others for funding for the survey, for the observatory, and scientists like you for the support of this program. But we also realized that now that we understand the system better, and also given that science is evolving, and given many excellent ideas that came from the community on how we could improve this baseline cadence, that it is worthwhile now to go through the process of final optimization of our baseline cadence, the cadence with which we will start the survey. Of course, eventually, we will know much more about the system itself. We will know much more how we perform. So we will continue improving, changing this cadence, this strategy. But for now, we need to have something to start the survey with. And so the intent is to make the final survey, the final data set, 10-year-long legacy survey space and time, as good as it can be, where the constraints are the performance of the observing system, observing conditions that we have in Chile, various science drivers that involve with time, and also scientists that are investing in its mission and legacy. So that was the reason why we formed SCOC about a year ago. And what we wanted to achieve is to have a committee that is expert, so that we get scientific expertise that we don't fully have in the project. There are, for comparison, there are a few dozen scientists on the project who could be deployed to work on this optimization, but there are over 1,000 people in science collaboration. So obviously we have much more expertise outside of the project than within the project. In addition to expertise, we also wanted this committee to adhere to our desire to have diverse project and diverse committees. So you will see the membership, it's very diverse. And we want this process to be fully transparent. We don't want to be some smoky room where people are making decisions without input from the community. So basically, you can think of SCOC members as managers of all scientific desires that they know about from their science collaborations. And now we are trying to manage this process. We are trying to distill all the relevant information into a set of rules that we will be using when we observe the sky. So that's the shortest summary I could give you about the SCOC. There are a few other presentations where there is much more background about what we want SCOC to do. And you can start with this link at the bottom of the page, where there are other links if you want to dig deeper and learn more about the SCOC process. So SCOC is charged with several things. It will be standing committee through the life of the Rubin Observatory operations, at least for LSST. So the first immediate task for the SCOC is to make specific recommendations for the cadence choices for the full 10-year survey. Again, we need strategy to start with. This is not saying that it's set in stone for 10 years and that if we realize how we can improve what we do, that we will not do it. Of course, we will do it. But we need now to agree on how we will start the survey. Then we need to communicate these recommendations to the science community, because we want to be certain that we are doing the best we can at the beginning of the survey. As the time proceeds, we'll learn more about the system and performance, but we want to have broad expertise that will agree with everyone that this is how we want to start the survey. Once we settle on this basic strategy for starting the survey, then there will be strong drivers to modify it a little bit during first 6 months or so to accomplish so-called early science observations. There was yesterday an excellent session organized by Lee and Guy, our project scientist for data management, and Bob Blum, the director of operations, where early science was discussed in detail, what it means and why we want to do it. And you can look at the recordings if you're interested. But basically, it's defined as all the science prior to data release 1. And the reason why we want to revisit then basic strategy is that we want to look carefully on how rapidly we can make templates for image differencing, etc. So there are more details in that session from yesterday. And then, as I said, during operations, we will carefully track survey progress. And then if we see that we can improve performance, we will make recommendations for changes in survey strategy. The survey strategy parameters will be managed. We don't have yet details about how we will manage these in operations, but it will be something that is carefully managed so that we know exactly what strategy we were using at what time as LSST progresses. So SCOC members are listed here. As you can see, we span US and the rest of the world. We have gender balance committee, and everyone on this list is expert in their own field. I also list after each name their science collaboration liaison information. So each SCOC member has science collaboration that they are liaison for, and each science collaboration has someone on the SCOC that is liaison for them. I emphasize this does not mean that these members are supposed to fight under quotation marks for that science collaboration. We aim to have balanced, rational process to get to the optimal cadence. There is much more discussion about that point in that first link I gave you a couple of slides ago. I will not go deep into this discussion about it, but we are supposed to come to conclusions by consensus, hopefully by procedure that is repeatable, meaning that if now we presented the same information that the SCOC is given, and we selected another dozen people from our science collaborations, ideally, they would arrive to the same conclusion. This is not about fighting for your science collaboration. This is more about diplomacy, about how to make the best cadence that we can have. So here is our immediate short-term schedule. So I will be talking about this draft phase 1 report in a couple of slides and give you a link for it. Our goal was to present it at PCW near on schedule. Then once you read this draft report, undoubtedly many people have many comments and many suggestions for how to improve it. And so in addition, there will be a new set of simulations that will be trickling in. And so we anticipate that community, our science stakeholders, would like to have another opportunity to provide feedback. And so we will have our second workshop. Our first workshop happened a little under a year ago. We will have our second workshop this November 16th to 17th. These dates are set, and there will be more information about logistics as we approach November. Given the feedback from that workshop, the SCOC will work hard for a month, and we plan to finalize this report that is now in draft form and deliver it to the operations director, Bob Blum, as a recommendation for the baseline strategy. Now, this is still not the final baseline strategy. We call it initial baseline strategy because there will be still some open optimization directions that we'll attempt next year. And so the full set of simulations that will be produced in response to phase 1 report will be delivered by the end of February. And then there will be at least 5 months for everyone to look at these simulations, to their math outputs, to metrics, to produce their own metrics and analysis. And then after 5-6 months, we'll gather together again and talk about how to do the final fine-tuning of the baseline strategy. That will happen sometime in 22, late in 22. And then after we agree on what we want to do, we will simulate the entire survey of that final strategy by the end of 22, fall 22. And based on this, we will deliver the final recommendation to the operations director, which we call phase 2 report. So we will say, this is how we want to start the survey. And here is simulation of that survey and its properties. There will be a report delivered by the end of the next calendar year. Now, between delivering this report late in 22 and our best current estimate for the start of operations, early 24, so we believe operations will not start before January 24, and we are hopeful that they will start no later than June 24. Our best estimate now is April 1, as you could have heard yesterday. So there will be a whole year, 2023, when we will pretend we have LSST, we have a simulation of that final strategy. And that will be time for everyone interested in this problem to analyze that simulation, that single simulation in gory detail. And if any problems are found, then we anticipate we'll have more input and perhaps we will modify that baseline cadence. At the same time, we expect that we will start commissioning the system. We will start getting real images, first with ComCam and then LSST Cam. And we will be learning more about the system performance. And it is likely then that we will be in a situation where we will want to tweak further some properties of the survey. For example, maybe our sensitivity as a function of wavelength will not be exactly the same to what we are assuming now. In this case, you would want to adjust exposure time per band to some extent, depending on what we find. So there will be more optimization, but again, it will not be anything fundamentally changed in the survey. These will be at the few % level optimization. The basic strategy that we will propose in phase 2 report will be maintained. Modulo early science modifications for the first 6 months. So how did we arrive to this draft phase 1 report? We solicited so-called Cadence Notes, which were supposed to be relatively short written inputs to the SCOC based on about 100+ simulations that our scheduler simulation team produced. And I cannot overemphasize how useful that input was. Thank you so much to all people who worked so hard to produce these Cadence Notes. Indeed, we now hope that most of these Cadence Notes will be published as journal papers. And when I'm done, then Federica Bianco, who led this whole effort to take Cadence Notes and publish them together in a dedicated ApJS issue, she will tell you more details about it. I'll just skip over it. But again, I want to emphasize that there is much more expertise outside the project in our science collaborations than within the project. And if we want to truly optimize this survey to its maximum possible extent, given boundary condition, it is very important that we continue getting input from science collaborations. So thank you all who are listening to our working on cadence optimization. Thank you all for this invaluable input. It is really fundamentally important to optimize the survey. Something is so slow with my page flipping, and I don't understand why. So a note on metrics. As you know, we use quantitative metrics to assess the performance of this large number of simulations. And so many Cadence Notes were qualitative. They did convey their points, but they did not have quantitative metrics ready to be fully incorporated into the math. And when we produce the next generation of simulations that Lynn and Peter will talk about in an hour, we would like to have all the metrics incorporated and automatically run for all these new simulations. So it is important for the community working on these problems to liaise with Rubin Observatory team, scheduler team, and that we finalize these metrics. That's the only way for us to assess how successful is some strategy improvement, let's say rolling cadence, unless we have metric that measures number of discovered transients that rolling cadence aims to increase, then we cannot tell you whether our implementation is really an improvement or not. So please, if you care about this, make sure that you deliver your metrics to Peter and Lynn before the end of this calendar year. And here are a few specific examples where we are kind of short on metrics. So we need to understand better some intra-night optimization directions. Like, do we do presto call? Presto caller is short for having 3 visits per night. How would we measure that this is better than having 2 visits per night? Or if we have various implementations of rolling cadence, how do we know which one is the best one? We need to have metrics that respond to these changes in the strategy. Similarly, there are about 9 or 10 so-called micro surveys that ask for 1 or 2% of time to be squished into the survey. If these proposals will be successful, they must have metrics that will demonstrate how greatly they improve some science. And finally, one area where we lack metrics is for doing galactic structure studies, especially in crowded regions, like in the bulge and in crowded regions of galactic plane. That's where we still don't know exactly how deep we want to go and whether we need to do additional processing of data or not. This is still an open research area. There is a little bit of ping pong because we don't know exactly how our processing software will perform, but at the same time, we don't know what are the science drivers, how deep should they go? But science drivers then say, well, we don't know how deep we could go, etc. So this is an open research area, and I strongly encourage all people working in galactic structure, especially in non-halo science in crowded regions, to help us do this. Okay, finally, to the main topic of the presentation, this draft phase report. So it's about 14, 15 pages. There are many details there. It's linked at this ls.st doc 37922. You can get it there. Full context is given there in details. I cannot go through the full report in every gory detail today, so I will just give you high-level conclusions. So the document itself is structured in 3 parts. So we first remind you of background and we give you information about the SCOC process. And then we list recommendations for phase 1, and they are structured around the same 7 questions that were published in the Cadence Notes solicitation and that were addressed in those 39 Cadence Notes. And then given the SCOC recommendations, after taking input from Cadence Notes on these 7 questions, Lynn and Peter developed a new set of simulations that they will discuss in detail in the next session. And there is still time to modify them or to propose adjustments to that list. So if you're interested in simulations themselves, I highly encourage you to attend Lynn's and Peter's session. So let me now briefly go through these 7 questions. So the first question was optimization trade-off between the sky coverage and the number of visits per any point on the sky within so-called wide, fast, deep survey. Our science requirements document has sweet spot for design at 18,000 square degrees and 825 visits over 10 years. And it is impossible to argue that this is not uncertain to at least 10%, maybe even more. So we wanted the science community to have another chance to tell us, is it really the sweet spot for all the science we want to do? And in short, the answer is, it's roughly okay, but it's not so important how many square degrees we have, 18,000 or 19,000. It's important where we place them on the sky. And so there are lots of good Cadence Notes that argued for various coverage. In the end, the most important conclusion is that we decided to define the wide, fast, deep survey by a limit on interstellar dust extinction that will serve extragalactic science, and with 2 declination boundaries. And then, given this, then there are additional areas, I think it's on the next page, additional areas that formally are also part of the main survey, but because of technical reasons, we carry them under different names. So there is about 8% spent for galactic plane coverage and 5% for the so-called North Ecliptic Spur. So we are around 93% with that. So at the percent levels, this is still optimization question. These are not God-given yet. They are not set in stone. We have about 5% spent now for deep drilling fields. It might be more later. There was consensus that this is where we would put additional time, etc. So for more details, look into the draft report. Then there is some indication based on the measurements of the procured components of the system that we may be slightly more sensitive in terms of integrated at undo than we anticipated originally. We are hopeful for 10%. Estimates vary between 10 and 15%, depending on details how you do it. But at least at this moment, we don't think that the system, the observing system, will be less efficient as a survey instrument than we anticipated. So we are hoping it might be even better by as much as 10%. So we asked what we could do with that 10%. And so we received proposals for so-called micro surveys that together add up to 12% of time. We define micro surveys as something that asks for between 0.3 and 3% of time. Together, they add up to 12% of time. To some, it will not sound as a lot of time for all that great science in those 9 proposals, but at the same time, it needs to be compared, for example, to 5% of time that deep drilling fields are currently allocated, and deep drilling fields are supposed to deliver great science too, in addition to help us understand better what we are doing with the main survey with your visits. So it is very hard optimization question, and we're still working on it. And at that level of optimization, we will actually need to wait until commissioning until we have the actual measurements of the performance of the integrated system. Then there was a very technical question about whether we should do 1 snap or 2 snaps in the U-band. In the U-band, the sky is very dark, and the readout noise, which is negligible in other bands for the nominal exposure time. In U-band, it hurts you to have two exposures in a visit. So we arrived to a consensus that we definitely want 1 snap no 2 snaps in U-band visits, just in U-band. For the rest of the bands, it's more complicated, and we will address it later. But for now, we want to model U-band with 1 visit, and we also see what would happen if we go to slightly longer exposures, which would bring U-band up to half a magnitude deeper. That's also partial in response to the fact that, as measured, our throughput is slightly skewed towards red compared to the original design that we aimed for. So that's an example of another optimization that we will attempt to do once we have the actual measurements. Then we also wanted to revisit the fraction of observing time allocated per band. So total is 825 visits. In U-band, for example, we have 56 visits. In R and I, we have 180 or 230, I forget now. So we need to ask, that was done 10 years ago or so, do we want to revisit these allocations? And it turns out that there were no strong arguments for significantly changing the default. Once we have real data, then we will revisit again. And then special regions like North Ecliptic Spur or Galactic Plane and Bulge, they may have slightly different band allocation. Definitely North Ecliptic Spur, where we don't even plan to take U-band and Y-band data. Then there is this question of, do you want to use the same filter or different filter in a nightly pair of visits? If you use the same filter, you can measure brightness derivative quite accurately, but you don't know anything about the color of a new transient. If you use different filters, then you can measure color quite accurately, especially for objects that vary on day or week timescales, like supernovae. And so decision was made by the SCOC that we will use different filters for pairs of visits, and how we will combine 2 different filters is left for further optimization. But there are some good ideas already submitted in various white papers and Cadence Notes. We wanted to also revisit the question of rolling cadence. Rolling cadence is an idea where instead of taking data uniformly in time, you get more data in a given period of time, and then you get very little data for the rest of it. Of course, integral is the same, but it's almost like if you think of accordion and how it looks like, you have these dense clumps. So we started implementing this idea about a couple of years ago. Andy Connolly, Steve Ridgway, they came with some good ideas that we implemented, and then we saw that there is potential. Since then, Peter Joachim and Lynn Jones developed next generation rolling cadence, and so far all the metrics that we have, which is not complete set, but all the metrics, like for example number of cosmological supernovae, show that this is a good idea. And so basically we want to continue this development. We don't have the final implementation or the final strategy for rolling cadence. It's still being implemented. And so we decided to form a task force, which will be led by our project team. And it will also include all science collaboration members interested in rolling cadence. Lynn and Peter will start by approaching all the authors of Cadence Notes that mention rolling cadence. They are listed here by individually, but that does not mean that if you're not on this list that you will not be accepted. If you have interest in rolling cadence optimization, that you should definitely contact this task force and help the work. And finally, there was question 7 where we talked about dithering. So we already have effectively dithering in simulations. And there was excellent work by Eric Weiser and his team who showed that you absolutely have to do dithering, and details of it at this stage are not super important as long as you do something intelligent, but there are many ways to implement it. So the conclusion is we definitely need to do dithering. We still don't have all the information, for example, about scattered light in the camera that might impact weak lensing systematics that are very small and are sensitive to such features. So we will have to revisit this question once we have commissioning data. But at least for now, we know that dithering is fundamentally important for the success of many science programs. So let me summarize here, and then I will stop sharing and will invite Fed to tell us about her efforts to publish Cadence Notes. So we are still optimizing the cadence. We are decreasing radius of convergence. We believe will converge by the end of the next calendar year with the final recommendation. But it is fundamentally important to remember that this whole process is dependent on inputs that we are getting from our stakeholders, from science collaborations, from the 1,000+ people interested to make LSST as good as it can be. So we will need to make many decisions over the next year and a half, but also we acknowledge that we still don't fully understand the system performance. We have to integrate it, commission, and once we start operations, we will see what assumptions we made in optimization now were incorrect, and we will try to re-optimize once we understand this. And now I got disrupted. Oh, here we are. And finally, there will be much more detail about new simulations in the next session. So I invite you all to join us in half an hour or a little bit more. I don't know what time it is, but I will stop sharing. So I was right on target, 30 minutes. So we have a few minutes from Federica, and then we can ask questions about Federica and myself. I see Leanne's hand. Say it again.
Yeah, I just put my hand up to mainly ask the chairs, do we want to queue up the questions to Željko as part of the talk now that have come on Zoom? Oh, sorry, Slack, sorry.
I would rather have Federica present her part, because I think with questions, it may become open-ended. And Federica led this effort that I really would like people to hear. And also Federica has some other constraints, so she may not want to wait all the way to the end. So I think it would be better to give Federica a chance to tell us.
Yeah,
Okay.
I will be brief, and I think I can stay until the end for questions on this, which I'm about to present. Let me share my screen. I presume you see my screen and you see now in presentation mode. So I'm gonna tell you about the.
Did anyone else lose connection? I was just kicked out.
Yeah, I think
okay.
everybody did. Yeah.
We're all coming back.
We're just missing Fed still.
Maybe she's looking for a link. I'll send her a link. While we are waiting for Federica, maybe we could now address questions for the first part.
Sure. Let me, okay, so there was a question about simulation versions from John, but I think this has been answered by Lynn. Michael Strauss asks a question about what we've done commissioning to understand the impact of satellite constellations. It's often said that we need the 2 by 15 second snaps to mitigate satellite trails. Are there things we can do for commissioning to confirm that we need these 2 snaps?
Yeah, 2 snaps in a visit is a complex issue that has many flavors. Originally, we wanted to have snaps because we were interested in rapid transients, and we were afraid it would be swamped by false positives due to cosmic rays. Can people mute, because there is so much background noise? So meanwhile, we learned from measurements and simulations that actually cosmic rays should not be that important, and that we could do it with 1 snap. And so we would save 2 seconds for readout. We would save on readout noise losses. So one would say, let's go with 1 snap. We don't need them. We said about a year ago in the project, let's not abolish 2 snaps until we have commissioning data. We can demonstrate that we can process them, that we can find CRs even when we deploy them, and then perhaps we should consider abolishing them in the interest of efficiency of the survey. And then these satellites happen. And the question is, are we going to be able to model them out easily and prevent systematics for measurements like desk-related weak lensing or similar, or do we need to basically throw away 1 snap in a visit because it has it has a satellite trail in it. Simulations show that we ought to be able to find them easily and mask them. But there is issue of these tiny level systematics where it's really hard to say reliably, is it an issue or not without having real data. So the bottom line is we must keep 2 snaps until we are convinced that we don't need them. They do represent significant loss of efficiency. It's about 8%. It's more than what we are allocating for deep drilling fields. But until we are convinced with real data that we can do away with them, we have to retain them in the baseline.
Okay, thank you, Željko. Do we have Federica back, or should we go on to another question? Okay, another question. I think that answers Željko. Michael Strauss again asks, can you speak further to how the early science decision process will integrate with the SCOC decisions? I know that early science planning really can't be finalized until we see how the science verification and commissioning pans out. How do we make the 2 decision processes work together?
Right, so ultimately, early science decisions are in SCOC charge. We split the work at this moment between the SCOC members focusing on defining the baseline survey and an early science team that is led by Leanne as a project scientist for data management and Bob Blum and a bunch of number people too. But we split it because it's a much more complicated issue from various aspects that also involve data management. We also don't know exact timing. It's related to commissioning. So we are doing it now separately, but ultimately once SCOC is done with the phase 2 recommendation by the end of calendar year 22, then 2023 SCOC will be fully focused on taking commissioning data and planning for the early science modifications of the baseline cadence. So that's the plan. I hope that's enough of an answer. I see Federica appeared. It wasn't just you, Federica. Apparently everybody lost connection.
But I was the only one that didn't know because I was screen sharing. So I'm going to go over my talk again. I just finished.
Oh, sorry.
No, it's okay. Thanks, Melissa, for calling me on the phone old fashioned to let me know. All right. I'm going to start from the beginning. I don't know when we got disconnected. The very beginning? Or...
We didn't hear anything, Fed.
Okay. All right, good. I had a good rehearsal. Let me share my screen. All right. You see my screen?
Yes.
And if I get disconnected again, Melissa, you know where to find me now, and I will pick up your call next time if it happens. Okay, so I'm gonna briefly tell you about the focus issue on Rubin survey strategy of the ApJS supplements that we are preparing to publish. So the idea here is that, as you know, if you're a member of the community, particularly if you're a member of the science collaborations, as you've heard from Željko, the survey strategy optimization and definition process has been a long community-oriented and community-driven process. And there have been many points in time where the community was invited to share contributions from their perspective, the perspective of their science and their expertise. This includes the work on the concept that was led by Phil Marshall that got published between 2015 and 2017. So this is the open live document, science-driven optimization of the LSST observing strategies. And then later, the white papers in 2018 and the Cadence Notes just this past year. Altogether, there are hundreds of people that have worked on these contributions, 467 unique authors for the white paper, 218 unique authors for the Cadence Notes. And also, I don't have the number on the slide, but if I remember, a few hundreds also on the concept. And so the idea was to provide a venue for people to publish the work that they have done and get, so to speak, traditional credits as is given in academic circles, so through a peer-reviewed publication that can count towards your CV, etc. When we have tried to publish things like science collaboration roadmaps and all sorts of preparatory work towards Rubin in the past, there's always a hurdle because journals, because these are not science results per se, and journals are really set up to accept science results and less so to accept preparatory science work. So the idea of having a focus issue on survey strategy is to overcome this hurdle on acceptance of the paper based on the scope. We partner with the AAS journals, and particularly with Chris Lintott on this, who will be the editor of this very focus issue, and who I think is online. So let me briefly show you. So focus issues, there have been focus issues of the journals in the AAS family of journals. So the idea is to have a series of papers that are a single collection on a specific topic. I want to emphasize that these are not hard, this is not a hard printed focus issue, which means that they're electronically accessible, which means that they don't have to be submitted simultaneously. They are accepted on a rolling basis, and they will continue to be accepted through the end of the SOC decision process, which, as you've heard, goes into 2022. The focus issues typically have an opening paper that sets the stage and contextualizes the publications within the focus issue. So we wrote the opening paper for this focus issue. It's been submitted to the ApJS, and it's been posted on the archive just a couple of weeks ago. Do look at it because it contains information that serve all the papers within, so that not each paper doesn't have to contain background information on Rubin, on why the process of survey strategy has been done with a community focus, or even on elements of the software that enable the contributions, such as the OPSIN and the math. That information is contained in the opening paper and can just be referred to in the following publications. I want to emphasize that the opening paper, the structure of the opening paper is, it contains a sort of historical recount of how the survey strategy process has developed, and how this idea of community-oriented survey design has been set up in all of its phases, from the COSET paper and even earlier, all the way through the Cadence Notes. It also contains information on the software that Rubin has produced to enable these community contributions, the OPSIN and the math. But it also contains a section on lesson learned and a look ahead for the continuation of this process for Rubin, but also for other surveys that may want to embrace a community focus plan of survey design, what they can learn from the process as it has been done by Rubin, and what we have learned from the process as it was. Again, it contains examples of graphics that will likely appear in your papers if you submit a paper, such as the maps or the radar plots, and it kind of explains why we use these kind of graphics and what they mean. So it reduces the need for having redundant background information in each one of the papers. So it's important that authors of the individual papers familiarize with this document. Finally, how do you submit a paper? As I said, this is a rolling basis submission. This submission is on a rolling basis, which means you can submit now. The portal has been open for a couple of months. You can submit through the end of the survey strategy optimization process, which, as we heard, will go into 2022. You submit the paper as through the normal AAS portal, selecting the APJ supplement series, selecting the instrumentation lab and astrophysics software track. This will get the paper directly on the right editor's desk, on Chris's desk. And you should include a note that says that this paper is to be considered for the APJS Rubin survey strategy focus issue. You can also contact me, and Chris has also kindly encouraged us to contact him directly if there are any issues. And also I recommend that if you're in science collaboration, you contact your science collaboration chairs so they can keep a tally of what papers have been submitted and make sure that they ended up on the right track of the APJ, of the AAS journals collections and on the right editor's desk. Lastly, if you were at the earlier plenary on the science collaborations, you heard about the Heisen-Simons Foundation grant, which has been awarded to a subset of the science collaborations. In fact, this award has been started from our request to support the publications within this journal specifically. So financial support is available for science collaboration members from any science collaboration, not just the 3 that are the direct recipients of the award, to publish their Cadence Note related work within this focus issue. It's not an unlimited budget, but based on the number of Cadence Notes that were submitted, we expect it to be sufficient to cover the cost of the publication of the Cadence Notes. And just one final word to say that the Cadence Note had a very specific structure that was driven by the need to contain the amount of reading material that the SCOC was subject to. So they were a Q&A, they had a Q&A structure that is not really a journal-friendly structure. So the idea is not to submit the Cadence Note perhaps as it is, but also you shouldn't think about this as a huge rehaul of the work that you've already done. It gives you an opportunity to show more background work, and it gives you an opportunity to show the results that you have included in the Cadence Note as well. And if you have written earlier papers, for example, the white papers of 2018, so long as they've not been published in other journals, they're also welcome in this APJ focus issue. I think I covered everything that I thought I was gonna have to cover.
Thank you, Federica. So I think we have 10 more minutes. We can entertain questions both for Federica and for myself, and I'm supported by a number of SCOC members here and Peter and Lynn.
So I just asked the chairs, I think I saw some hands up in Zoom. How do you want to do this one? So the Zoom questions, the hands up, or shall I go through the Slack questions?
I thought we were not using chat, but if you see the questions, can you just please read them? And
I did see a hands up. Okay, so continuing on from the questions that we had before, Stephen Smart now asks about microsurveys. He says his feeling is that from reading them in the SAC that many were effectively telescope proposals in the sense that we have always submitted proposals for targeted telescope time. I felt they weren't augmenting the LSST and its goals and not enhancing the survey aspect. They may well represent very good original science ideas. I think the question is, given these examples, should a fraction of the LSST time be given to microsurveys, and how should a wide call for, say, X% of time be managed? There is quite a discussion here.
Well, we went through this, right? So I would fully agree that you will not use Rubin Observatory to observe one object at a time. Now, these 9 proposals that SCOC selected, they all made a case for why would it be a good idea to use Rubin Observatory to accomplish those science goals. They were quite competitive if we had open competition process. Now, this is not an open competition process. This is optimization of Cadence, and there were a few specific modification of Cadence that would enhance science of LSST, but then again, something else will have to give up. So that brings us again to this question of metrics. For many of those, we did not have ready metrics that we could use to say, you will improve this by that many %, but you're gonna lose on this other science. So we don't have quantitative answers yet. Indeed, for some of these proposals, it wasn't even fully clear what would be their effect on what would be, it's not just time, but it can be various other second order perturbations on how it take data. So SCOC decided to just produce 10 simulations. And these 10 are each of these 9 little proposals implemented separately as a perturbation on the new baseline. And then we said, let's just do all of them. Let's just burn 12% of time and then see what happens. And the idea was that eventually, on time scale of few months, we may have metrics that will allow us to assess what's the impact. And since this is just simulation at this time, it doesn't cost us as much as it would with real telescopes. So just let's learn more about these proposals and see if they could nicely play with the rest of the survey or not. Now, if you wanted to have open call for tiny proposals, let's say hypothetically, let's take 10% of LSST, maybe it will perform better than we expected. Let's take 10% of Rubin Observatory observing time and say, this is now open to everyone to propose bright things with this large field of view camera. That's doable if there was consensus between all the stakeholders. If operations director said this is a good idea, if the head of science in operations for LSST said, yes, I think we can accomplish goals of LSST with 90% of Rubin Observatory time. So then instead of doing more time on deep drilling fields, maybe we should just open it to everyone to propose. So that's an option. I don't see why why would we say at this time that this is a bad idea? Maybe it will be a good idea. So we will revisit once we are in, let's say, a year of operations. These are tiny effects. These are 10%. None of these 9 proposals that we read, I wouldn't call them proposals, ideas. None of them must be executed in year 1. So I would argue, let's keep them on the bookshelf. We will not forget about them, but let's not push it too hard for year 1 when we don't know much about system performance, when we don't know much about how our data processing is operating. So these are all great ideas, but I would argue that let's not focus on that part in year 1. What we really want to focus in year 1 is what we call early science. We want to build templates as rapidly as we can that we start delivering time domain science while not departing too much from baseline, so that data we would get to building this template is also built to the main survey, that this data eventually will contribute to the co-edit depth that we will be using for static science at the end of the survey. Okay, maybe I spent too much time on answering this question. We only have like 3-4 minutes left. Do we have more questions?
Yes, we do. Chuck asks, to what extent are the simulations going to explore sensitivities to technical observatory performance parameters?
The simulations we mentioned today will not. If Chuck wants to simulate something else within the project, he knows where Lynn Peter live and can tell me, and will. But this is beyond. These simulations are focused on scientific return from the survey. There are some other simulations that we certainly can do, but that's something that we should discuss and optimize within the project. There is no need to involve 1,000 people.
Fair enough, Joko. We'll work on that offline.
Okay, and there are
Yep.
2 other questions. I think they've been adequately answered. They're about software papers and publications in ApJS, and Chris has answered both of those in the discussions satisfactorily, I think, to both Meg and Peter.
Good.
That's it then for questions on Slack.
Okay. There is something on chat. What is that? Okay, good. So, well then, thank you all for coming. There were many people on the call. And let me thank again everyone who participated in this cadence optimization process. Foremost, our SCOC members who had many, many telecoms and will have many more. But also to all people who are, I see every day on Observing Strategy Slack, contributing things and ideas, writing software, providing metrics, engaging your students. These are great things also for engaging students to analyze simulation outputs. So thank you all. Hang in there a little bit longer and we'll start getting real data, then we'll have fun.